My presentation is on the radiation environment of the solar cycle 25 maximum and how that's very similar to the previous solar cycle. Here on the first slide, you can see the dose rates observed by crater, three pairs of detectors. In here, you see my cursor, right?
Yes, we
okay.
do.
Okay, thanks. So here we see the maximum of cycle 24, which is around the year 2014. You see how the dose rates drop to values like on the order of less than 0.02 centigrade per day during the solar maximum of cycle 24. And then we see the current dose rates. These are like the most updated dose rates up until a week ago values. And you see how that reaches values even lower than what we had observed during the maximum of cycle 24. Actually, one of the reasons this is very interesting for us is that cycle 24 has exhibited lower than average solar activity, so that it has caused speculations that we might be entering an era of lower than average solar activity for several cycles. So far, we see that the GCR rates, however, are decreasing to lower values than what we had seen for the maximum of cycle 24. How does it go to the next slide? Okay. So we here in this talk, I try to review two of our previous papers and then provide an update to that. So based on these speculations, we decided to compare cycle 24 to previous era of low solar activity, like the Dalton and Gleisberg era, which were in the beginning of 19th century and 20th century. So we compared cycle 24 to cycles 5 and 12, and we try to project the results from cycle 6 and 13 to see how would that affect the radiation environment. So to do that, first I need to explain about modulation potential that actually describes the interaction between GCRs, galactic cosmic rays, and the heliospheric magnetic field. There's a previously examined correlation between the modulation potential and solar wind parameters. Here you can see that correlation. Here we use modulation potential based on crater measurements, and we compare that to we create that correlation based on the values that we get for the heliospheric magnetic field and solar wind speed. So you can see that we considered the same slope from this correlation. And what we actually did was we tried to use the same slope, use the values observed for the Gleisberg and Dalton era, and try to see how that would affect the modulation parameter value. And also, other than this, we noticed that in this correlation, we actually see some sort of a hysteretic behavior. Based on this hysteretic behavior, we did another analysis. So actually, when I said two papers, one of them was our 2020 paper that we try to project radiation environment based on a Gleisberg-like and a Dalton-like solar cycle 25, and also another study in 2022 where we use those correlations and their shape to actually predict how cycle 25 would be. So you see those projections in green and blue for Dalton-like and Gleisberg-like cycle 25. And the red here is what we have observed so far for cycle 25. And you can see how that is very similar to cycle 24, which is the gray, and also a slightly bigger, but it's still very close to a Gleisberg-like cycle 25. And also in our 22 paper, The red line here and the dashed red lines show our prediction of like how this correlation should be. And as you can see, the red data points is closely following that prediction. So here I have the heliospheric magnetic field. These are the model values, the black, the solar wind speed, and the modulation potential parameter. So based on the three parameters that we use in those correlation diagrams. And you see the green and blue, which is the Gleisberg-like is green, and the blue is a Dalton-like cycle 25. So these are those projections from our 2020 paper. And then the red dashed line, or the maroon, I guess, dashed line you see here is our prediction based on our 22 paper for the maximum of cycle 25. So we have our predictions for the heliospheric magnetic field for the maximum of cycle 25, and also for the modulation potential parameter. What you see here in purple is the modulation potential parameter based on GCR dose rates observed by crater. And you can see how, and again, you can see how this is coming closer and closer to reach that predicted cycle 25, and how it's also very close to what we have seen for cycle 24. Of course, this isn't as updated as the plot I showed you in the first slide, which we expect the modulation potential to slightly pass this line and what we have seen based on crater data. So here I have the modulation potential in a closer look for the Gleisberg, for the Dalton, like cycle 25. What we saw for cycle 24 is the dotted black line, but the maroon dashed line, that is our prediction based on our more recent paper, 2022 paper. That is, again, very close to what we saw for the peak of cycle 24. And the red is from crater data. And these are the dose rates. Again, you see the dose rates fall slightly below what we saw for the maximum of cycle 24. So far what we have seen is that the radiation level is lower than the maximum of cycle 24, and it's very similar to a Gleisberg-like cycle 25. So from here, we want to see if cycle 25 will present a safer radiation environment in general. Again, this is an update from our 2020 paper, where we show the permissible mission duration separately for male and female 45-year-old astronauts. And you can see again green and red Dalton-like and Gleisberg-like cycles, cycle 25, and also the maximum of cycle 24. However, for these predictions back then, we used values based on, we actually calculated the permissible mission durations based on the standard that NASA was using back then, which was based on a 3% reduced exposure, induced death at a 95% confidence level. But since then, NASA has moved to a new standard that is actually at 600 millisievert for all astronauts at all ages. So this new standard is actually based on 35-year-old female astronauts. So that may sound more limiting, but since it has removed the 95% confidence level, it actually allows for higher values of effective dose exposure. So this has caused the new prediction for the maximum of cycle 25 permissible mission duration to increase by like more than twofolds. So this is what we see for both male and female astronauts at all ages. The reason it is so much higher than what we had predicted in our 2020 paper is because of NASA using a new standard. So to compare apples with apples, here I have a plot that shows the permissible mission durations based on the old standard for all the solar cycles all the way back to 1750. And you can see this is the peak of cycle 24. And like comparing it to, for example, to the space age, and especially the time of Apollo 11, you can see how the permissible mission durations is significantly lower. Although this value is, as you can see, much lower than what we had back then, but since NASA has allowed for like
We're over 10 minutes already.
Okay, this is my last slide. So this means at least we are good for the lunar travel, and that's it.